8.6 is about choosing an appropriate method for factoring a polynomial. And we are going to also combine methods for factoring. In other words, we're going to see more of them today where you have to actually factor out the greatest common factor first, and then after that factor the trinomial or difference of two squares or something like that. So let's just get right into it then. Whenever we are factoring, the first thing you should always look for, okay, number one, when it's asking you to factor, look for a greatest common factor first. Okay? So here we have 10x squared plus 48x plus 32. The first thing is, do they have something in common? Well, they're all even numbers, right? So they only have 2 in common. All right. Is there any other number besides 2? Or let's see. Here we have our first one is 10. So we know the factors of 10 are 2 and 5, right? Okay. Does 5 go into 48 or 32? No. Okay. So our greatest common factor here is 2. So the first thing we're going to do is factor out the 2. So we divide everything by 2. All right, now we need to look to see if we can factor that. Well, first of all, I'll look for perfect square trinomial. Is this a perfect square trinomial? What's left in the parentheses? No, because the 5 is not a perfect square. All right. So then we have to use our other method then for trying to factor trinomials with a different than 1. So we will multiply the 5 and the 16 first. So if you're using the box method, you're still going to be doing the X box. So 5 times 16 is 80. So we need to find the factors of 80 to add up to 24, if there are any. All right, so the factors of 80, 1 and 80, do those add up to 24? Okay. Remember, they're both positive here. All right, so we're adding them together. 2 and 40, does that add up to 24? Let's see, does 3 go into 80?
20.
No, but 4 does. 4 times 20 is 80. What's 4 plus 20?
24.
All right. So we're going to do 5x, and I'm just putting it down here off to the side because my final answer I'm going to put up here. I'll use a different color also. So we have 5x plus 4 and 5x plus 20. Remember, we take the coefficient of x squared and put that with both x's in the first term, and then our pair of numbers here go second in both of them. So 5x plus 4, can I simplify that any? No. How about 5x plus 20? They have 5 in common, so I'll divide both of them by 5. So my final answer is 2 times 5x plus 4 and x plus 4. And there is the answer. Right? So the first thing we've got to do is see if there's a greatest common factor. Once we factor that out, then we look to see if we can factor what's left. So let's look at letter B. Always look at the constants first. 8 and 18, do they have anything in common? Okay, they both have 2. So then we look at the variables. What do they have in common as far as the variables are concerned? So we have x to the 6 and x squared, so they have x squared in common, and they both have a y squared. So my greatest common factor is 2x squared y squared. So we take out that. So what do we have left? 8 divided by 2 is 4. We had x to the 6 here. We took out x squared, so we have x to the 4th left. And y squared, we took the y squared, so we don't need any more y's. 18 divided by 2 is, so we have minus 9, and we took both the x squared and the y squared from here, so all I have there is 9. So now I look at my result then. What's in the parentheses? I have 2 terms separated by a minus sign. So I should check to see if those are the difference of 2 squares. So is 4x to the 4th power, is that a square? 4 is a squared and x is raised to an even power, so they are. Okay. Is 9 a square? Yes. So then I can factor that one also. So we have 2x squared y squared. That always stays there in the front. 4x to the 4th, that's 2x is squared plus 3. And 2x squared minus 3. So we look for the greatest common factor. And then what we have left in the parentheses, can I factor that? All right, so you do A and B down here and then check it out. So you have to take your time with these. Find the greatest common factor first. Factor that out. And see what you got left. So, methods to factor polynomials. Gentlemen. So the first thing for any polynomial that we're looking at, always looking to factor out the greatest common factor. All right, so here's some rules of things you're looking for. If it's a binomial, all right, we look for a difference of 2 squares. So that's 2 terms. Trinomials, we want to look to see if they are perfect square trinomials first. If they are, great. If they're not, then we look to factor them other ways. If it's just x squared, then we have x plus some number and x minus some number maybe. If it's ax squared, then you've got to use your alternate method or the box method then. And anytime there's 4 or more terms, we want to look to factor by grouping. So we'll use those methods. If none of the factoring methods work, then it's just unfactorable. And sometimes that happens. Letter A, 9x squared plus 3x minus 2. So number 1, find the GCF. Is there a greatest common factor here other than 1? All right. 2 does not go into 3 or 9, so no, we don't. All right. So it's a trinomial. So we look to see, is it a perfect square trinomial? So is this one a perfect square? Well, 9x squared is a perfect square, but 2 is not. So it's not a perfect square trinomial. So then I have to use my other methods for when I have a trinomial in the form of ax squared plus bx plus c. So we multiply a times c together and we get negative 18, right? 9 times negative 2. So I need to find a pair that of factors that when I combine them, I get positive 3. So we would have, since the 3 is positive, my bigger number is going to be positive. So negative 1 and 18, nope, that doesn't work. Negative 2 and 9, that's 7, right? 9 minus 2 is 7. Negative 3 and 6, does that equal 3? Yes. Right. So, we have 9x minus 3 and 9x plus 6. And we factor the greatest common factor from those pairs. Well, these both factorable by 3. Those are both factorable by 3. So 3x minus 1 and 3x plus 2 would be my answer. All right, so you try letter B. Right. Multiply a times c, 2 times 4 is 8. Factors of 8, 1 and 8, 2 and 4. None of them add up to 5, so this is unfactorable. Okay. And sometimes that'll happen. All right, letter C. Sam, do they have anything in common? Yep. And what would it be, since it's most likely? Does the 72 have a y? So they don't have a y in common. So we've got the numbers 4, 12, and 72. Okay, they're all even, so first of all, so I can try 2. But what about 4? Does 4 go into 12? Does it go into 72? Well, try it. Take your calculator and see. All right, so we start to take out the 4. So we have y squared. 12 divided by 4 is 3y. 72 divided by 4 is what, Jacob?
18.
What? 18, okay. So now we factor this. Put my 2 sets of parentheses because it's a trinomial and the coefficient of y squared is 1. So what are the factors of negative 18 that add up to 3? Okay. So we put our y's here and here. Do the same thing we did up there earlier. So negative 18, negative 1 and 18 because it's a positive 3. Wait a minute, we had one with positive 3 a minute ago, didn't we? All right, that was negative 3 and positive 6. And there's our answer. So if you need to make a factor tree, do it, please, whatever it takes, or use your calculator. All right, if you remember, we could just put negative 18 divided by x and our y equals, and that would help us also. All right, letter D. Brandon, do they have anything in common? X to the second, good. So we take out x squared. I'm left with, well, if I took 2 out, okay, I have 2 left. So x squared minus, if I take x squared out of x squared, what am I left with? A 1. Because remember that if I distribute these, it's got to equal that, right? And if I put a 0 there, what's x squared times 0? 0, because anything times 0 is 0. Right? So, hey, I have 2 terms separated by a minus sign. So are these the difference of 2 squares? And the answer is yes, because this is x is squared here, right? What number squared equals 1? 1. So we get x squared times x plus 1 times x minus 1. Okay, so that's the whole thing of what you're doing today then is A, looking for a greatest common factor. After you factor that greatest common factor out, can I factor what's left in the parentheses? If you can, do it. If you can't, then you're finished. Right? If you can't factor anything, then it's just unfactorable.